Welcome to Spring LIB.
For this problem, we have been given 5 different sequences. Each sequence is defined by a recursive relation with an initial condition. So it's enough information to get us started on our sequence. And we need to find the first 5 terms of the sequence. So let's begin. Let's do the very first one. Says my a to the n is going to be 6 times a to the n minus 1, where a to the 0 equals 2. So our first term is 2. We've been given that. Now, our recursive definition says to get to the nth term, I take 6 times the previous term. So to get to a sub 1, I'm going to go to a sub 0, which is the one I already have here, times 6. So that's going to be 2 times 6, or 12. Now, to get to that third term where it's a sub 2, I take 6 times the previous one, a sub 1. So 6 times 12 will be 72. And again, I just keep multiplying each successive term by 6. So those are our first 5. Again, we can keep going. This sequence doesn't stop with 5 terms. That's just as far as we need to go for this particular problem. Okay, let's go on to B. This time, a sub n equals a sub n minus 1 squared. And we're told that a sub 1 equals 2. So first term is 2. To get to the nth term, I take the prior term and I square it. So a sub 2 means I square a sub 1. Okay, I've got a sub 1 is 2, so I'm going to square that, and that gives me 4. Okay. For the third term, I square the second term, 16. For the fourth term, I square the third term. 16 squared is 256. And then I square 256, and I get 65,536. Hey, what about number 3 here? This time I have a sub n equals a sub n minus 1 plus 3 times a sub n minus 2. And so in this case, they've told us that a sub 0, our first term, is 1, and a sub 1 is 2. So they've given us the first 2 terms. And the reason they've given us 2 is because this recursive definition looks at the prior 2 terms. So to get to the third one, which is, since we started with a sub 0, to get a sub 2, I'm going to take a sub n minus 1, so a sub 1, plus 3 times the 2 prior one, a sub 0. So 2 plus 3 times 1 is going to be 5. Okay, now let's get to that fourth term, a sub 3. I take a sub 2, which is 5, plus 3 times a sub 1, which is 2. So this is going to be 5 plus 3 times 2, or 11. Okay, and for last one, we're going to take 11 plus 3 times 5. Again, we're going back 2 different spots each time, and that gives us 26. Okay, number 4. A sub n equals n times a sub n minus 1 plus n squared times a sub n minus 2. Okay, so again, this one, because we have an n minus 1 and an n minus 2, they have to give us 2 numbers to start off with, and they do. They both are 1s to begin. So let's take a look at what we get. This is a sub 0 and a sub 1. So a sub 2, this one right here, I'm going to take 2, because that's the value of n, times the previous one. So 2 times 1. Okay, again, n is 2, so 2 squared is 4, times the entry 2 previous, which is also 1. 2 plus 4 is 6. Okay, how about the next one? Now n is 3. So I have 3 times the prior one, so that's going to be 3 times 6, plus n squared, since n is 3, that's 9, times the entry 2 previous, which is 1. So I have 18 plus 9, which is 27. Okay, and our last one, now n is going to be 4. So I have 4 times the prior one, which is 4 times 27. N squared, that's 16, times 2 previous, which is 6. And when I put all of that together, I get 204. Okay. So some of these you can do in your head fairly easily. Some of them it helps to write down the intermediate steps just to keep everything straight. Okay, last one. We have a sub n equals a sub n minus 1 plus a sub n minus 3. Okay, so we are going back 1 and then 3 behind. So in this case, they have to give us at least the first 3, which they do. We start with 1, 2, and 0. So this is a sub 0, a sub 1, a sub 2. So our next one is going to be a sub 3. So n is going to be 3. I go back 1 spot, which is 0, plus the 1 3 places back, which is 1. So that value is going to be 1. And now if n is 4, I go 1 position back, which is 1, plus 3 positions back, which is 2. 1 plus 2 is 3. So that is the first 5 terms of all 5 sequences in this problem.